today we see a lot more environments where you have, let's say, even 10 queues between the different computes, just because it's so easy to add them and you don't have to think twice. And that's usually where the observability is broken.
This is DevOps Paradox, episode number 164, How to Monitor and Debug Microservices. Welcome to DevOps Paradox. This is a podcast about random stuff in which we, Darren and Victor, pretend we know what we're talking about. Most of the time, we mask our ignorance by putting the word DevOps everywhere we can and mix it with random buzzwords like Kubernetes, serverless, CI/CD, team productivity, islands of happiness, and other fancy expressions that make us sound like we know what we're doing. Occasionally, we invite guests who do know something, but we do not do that often since they might make us look incompetent. The truth is out there, and there is no way we are going to find it. P.S. It's Darren reading this text and feeling embarrassed that Victor made me do it. Here are your hosts, Darren Pope and Victor Farsick. When we think about microservices and we think about containers, eventually we get to observability and monitoring, right, Victor?
Yeah, unless you fail before you even reach that stage.
We would never fail, right?
You never know.
So to talk more about this observability and microservices and everything that goes along with that, we have Aviad on from Lumigo. Aviad, how are you doing today?
Hi, I'm doing fine. Thank you for having me today.
So what's the big deal about microservices? I mean, I think one of the core beliefs right now is that modern software development gets to the point of having lots of microservices, whether that's serverless or whether that's containers. And I imagine those implementation details actually cause great pain within observability. But let's ignore that for the moment. Why do we believe that modern architectures are really microservices?
When you look at these new environments running in the cloud, usually, you can see that they're made up of a lot of components, different components, either in the compute or database, API gateway, and so on. The more that we go forward, the different R&D teams can actually break up their services into smaller and smaller pieces, which is great. It allows them to drive forward with a lot of small changes, especially if they have the right CI/CD in place, get a very robust application in place. But the more we go into that space of microservices, it means that my system is built of more and more parts, and it's just becoming harder to understand how does my overall system look like. It's harder to get that observability.
Why is it harder to get that observability? I mean, it seems like, hey, here's my program. I can put in open telemetry or fill in the blank however I want to metric the thing. Why is it harder?
Because I think that the connections between the different components is becoming as important as what's happening inside the components themselves, right? So it's not only a Lambda or a container calling one DynamoDB. It can be a long chain of events of different computes calling different databases. And then where we usually have metrics and logs explaining to us what's happening, it's becoming harder and harder to understand exactly what brought to this high latency or what brought us to a specific crash. Because we see we have a crash, the metrics jump up, we take a look at the logs, we see maybe some explanations, but in order to understand the real issue, to get to the root cause, we need to get upstream to the beginning of the chain of events, for example, to that API call that started it all, and understand exactly what data was being moved from one component to another, until it finally reached that container or Lambda that crashed. And without seeing that, without understanding that, it's almost impossible to understand really what happened. I can always check my code. I can see if somebody pushed something trivial, right? Like division by 0. Okay, that's easy. It doesn't matter if you have microservices or anything else. You need to go fix that, and that's it. But sometimes you take a look at what started crashing this morning, and nothing changed. It's exactly the same container it was yesterday and the day before. So probably something else changed in your system. And without having those traces bringing you exactly to the root cause that did change, it's almost impossible to solve it quickly. Now, the tracing part is also becoming harder and harder as we go into this more modern environment where we have different components running from different places. A lot of them are managed services, so we actually can't add our own traces to it. You mentioned Open Telemetry, which is a great initiative, and we're seeing it more and more, but still, most of the services running don't have Open Telemetry in them. So we need some way to understand how can we connect the dots. That's one of the main things that we do at Lumigo. We are able to add our tracer to different places inside your code fully automatically, and we can talk about why it's so important that it's automatically, and we can show you full traces end to end.
When is that addition of the code happening? Is that at the compile time, or there is some kind of intermediary between me pushing code to, I don't know, Lambda or Lightsail or whatever it is, and actually being deployed there?
Right. That's a great question, Victor. And basically the answer is the user can choose where is the best time for him. In any case, it's without any changes to the code itself. It can be done through different, for example, in Lambdas, we do it with AWS Lambda layers, allowing me as a new Lambda is being pushed and starts to run to instrument it fully automatically. And I'll say why it's important. It's important for two main reasons. One is, as we said, in microservices, we have a lot of services. So it's not choosing just these three main components I have and starting to trace them and monitor them. It can very quickly reach dozens and then hundreds, and we see users who have thousands of services. And it's obvious that they can't go in and add their own pieces of code to each and every one of them, because when they try to do that, usually the devs or the DevOps start to forget, or they don't have the time to do it. So it's very clear that it has to be fully automatic. But also the second part is you have a lot of different types of compute, of services. And you don't want to start thinking about, for each of the different components, how can I add the specific tracer that's needed. So having that being done automatically is crucial as your environment becomes bigger and bigger. Some users like to have it as part of their CI/CD. So every time a code is being pushed into the CI/CD pipeline, the tracer is added. Some use the deployment tool itself, and some do it actually in runtime. So every time something reaches production, then it's automatically traced.
Yeah, so kind of you almost explained the evolution that we are experiencing completely outside of tracing, right? In the past, we were instrumenting one way or another. It doesn't matter. Let's say SSH certificates, right? Applications themselves. Then we started doing that through some sort of automation. And for most of the cases today, we do neither, right? We simply have systems that attach certain components to our applications when they are deployed on their destination, whatever the destination is, right? I'm assuming that you're talking about similar to what would be equivalent to attaching sidecar containers automatically to Kubernetes applications in Kubernetes, right? Except that we are not talking about Kubernetes, but managed services, right?
Right. So it can be, the containers running in Kubernetes and or managed services or Lambdas, but I think that's right, because I think that there's more and more focus on how do we increase development velocity, and in order to do that, we need the developers, as much as possible to focus on their core application. They have so many tools to choose from, it's so easy to add different services and different containers even to your Kubernetes. So you want it to be automatically the instrumentation part without having to, first of all, teach each team how to do it, but also so they have to think about it as little as possible. So they can focus on the main application they're developing, and all the rest will hopefully happen automatically. So and they get the tooling they need, in this case, observability.
But how does that work for managed services? Because if it's Kubernetes, you mentioned, there is basically nothing to be done by neither CI/CD pipelines nor developers or any of those things, because you label a namespace, let's say, or any of the similar method, and every application in that namespace gets a sidecar container that has tracing or metrics exposure or networking or whatever, right? But how does that work with? Can we do that same thing with something similar with managed services, meaning without involving any action on our part? And when I say our part, I mean either human or, let's say, pipelines.
So I think that managed services is exactly where it becomes most interesting. Because on one hand, managed services is the way to go, right? The more managed services you have in your system, it means you need to develop less code, you build less, and you're leveraging what your cloud provider is giving you. So, for example, in our own backend, we heavily use, we're running on AWS, and we're using Kinesis and SQS and SNS, just for example, as the way to move data from place to place. In order to be able to trace that, you actually need to infer from what's happening on both sides of that managed service. Because from that managed service, usually all you get is metrics. And as long as everything is working, that's all you need, right? You don't care. As long as everything is good, you don't want to know what's going inside of that managed service. That's part of the magic. But when there is an issue, and let's say a metric spikes or some customer gives you a call and you understand something is not working correctly, the way to understand what's going on is by inferring from the two sides of that managed service. So let's take that Kinesis as an example. You have maybe a container on one side and a Lambda on the other side. And by instrumenting the API calls made on both sides, you're able to get a lot more information. So by looking at the metadata being passed along the data itself, you're able to make those connections and build the full traces, even when you have fully managed services in between. So today we see a lot more environments where you have, let's say, even 10 queues between the different computes, just because it's so easy to add them and you don't have to think twice. And that's usually where the observability is broken, right? On the Kinesis, or even DynamoDB Stream or AppSync. That's where observability is broken. But by knowing which parts of the metadata to look and running the right correlation, we're able to build a full transaction end to end, even though it has a lot of fully managed components between the different parts.
But that interception that is happening between, let's say, a Lambda or then a container or whatever it is, right? How is it created? Or at one let's put it this way: at what point of a life cycle of, let's say, in a Lambda, that interception was generated, or the process that intercepts, right?
Right. So let's take that Lambda as an example. So once you instrument that Lambda using different features that AWS provides, again, I'm focusing on AWS for a second, you're able to have your library be called even before the first line of code runs in the Lambda. By doing that and adding runtime specific code, you're able to instrument the different API calls. So The basics one are HTTP calls. So if you know to listen to the HTTP calls and know what to listen for, you can actually pick up the different API calls being made, recognize what service is being called, the specific resource inside of it, and also pick up specific, let's call them fingerprints, which allow you to make the connection on the other side if you collect the same fingerprints when another Lambda is invoked with those fingerprints. So you start running when the Lambda runs, you add your instrumentation, and that allows you to collect only the metadata that is required in order to make those correlations.
So we were talking about Lambda at that point. When you're saying Lambda, are you saying the function as a service part of Lambda or something else?
That's exactly what I'm referring to, the Lambda as a service. So in general, when we're talking about serverless, the way I see it, it's the whole serverless ecosystem, right? It's any service which you can run and be oblivious to the servers running it. Cost-wise, robustness, scale, and so on. Lambda is the code as a service, which allows us to do that. That's the FAS, function as a service, which allows the application to be completely serverless. Because we had serverless components for a long time, right? S3 buckets, for example, where you can just throw your files in. We had that for a long time, but when the serverless Lambda came along, that was the turning point where you could write complete applications in the cloud with all the components you needed, starting with AppSync as GraphQL, for example, and then Lambdas and whatever serverless database you wanted.
The reason why I brought that up is traditionally people think Lambda, they think function as a service, but serverless also covers containers as a service. Because again, going back to what you were saying, we don't care about the service that's actually running whatever the code is. And to me, instrumenting something that is a container as a service makes more sense because that is a long-running, persistent, quote-unquote, type process versus function as a service, which is it takes X amount of milliseconds or seconds or minutes to run, but then it's just done. So what are the big differences when we're thinking about the instrumentation, ignoring the implementation details of it a moment? What are the big differences when we're thinking function as a service versus a container as a service?
I'll just say that serverless, does it include containers? And for example, Fargate, that's a big philosophical question, which has a lot of arguments around it, but it really doesn't matter. So I think that serverless and Lambdas, for example, that's where you get the most hyper-distributed environments, very event-driven, and as you said, running for short times. That means that you create a lot of different pieces. But I think that in the end, containers are usually very similar. We do have cases where you have, one big container running for a very long time. It can be, hours or days. And in that case, maybe the tracing is a little less interesting, right? Because if all of the logic is happening inside of one container, even one or two, you don't have a lot of questions exactly of where did the issue happen. But if we're going to different containers doing different things, then it becomes more and more similar to serverless. I can even tell you that when we started Lumigo back in 2018, we were very focused on serverless because that was where the most issues were concerning traces and people feeling blind. But actually, as time progresses, we see more and more containers in these very distributed environments. And we see a lot of environments which have both serverless and containers serverless, like you called it, and a lot of managed services between them. And in that sense, if I put aside the technical question of how do I instrument each and every one of them, they are very similar. The differences is usually when we go to the metrics, right? Because in Lambdas, you usually don't care about CPU and you don't care too much about memory, But when I look at the containers, at ECS, at EKS, I do start thinking about those lower level of infrastructure. I do want to see when I'm starting to run out of memory, when the CPU is too high, how many tasks are running. I just have to be aware of more levels of infrastructure. And the way I see it, that's the main difference.
There is also the challenge of the things you do not really control, right? Because if I understood right, you said that basically you need to trace both ends of every piece of the communication, right? And then, okay, yes, I have my applications. There can be Lambdas, there can be whatever. And I can instrument that one way or another to get tracing. But what do I do with third-party applications or services? Let's say maybe my Lambda is talking with MongoDB running in Atlas, right? Or, I don't know, Kafka. I mean, at the end of the day, there is always, even if we go 100%, perceived 100% functions as a service, which I don't think is doable, but even if we do that, there is still that everything else component, right? There is no such thing as a stateless system, right?
Definitely. And as I mentioned, like always, Lambda is just part of the environment. It's never the whole environment. No environment is complete code, complete compute. Also, usually the environments include both Lambdas and containers. And when we go to those third party, like MongoDB running on Atlas Cloud, or if it's something internal to AWS, like if we're talking about MongoDB, the other part of it would be DynamoDB, like in AWS. It's the closest thing maybe. That's exactly where it becomes interesting, right? So almost, I think, I won't say 100% of our users, but I see it in most of our users, everybody uses third parties. So they don't only use AWS or GCP or Azure, they also use services outside of the cloud just because, they found some best of breed and they want to use that. And that goes back to the ability to instrument the code in the right places. So if you're able to instrument, like we do, the code calling MongoDB on Atlas, you're able to see exactly the latency, how much it took the call to the to the MongoDB call to be made. You're, for example, able to see if there were 20 calls, and this is something that we had one of our users. There were, you can see in the graph call, you can see there were 20 calls to MongoDB instead of one batched. And once he saw that, he was able to say, okay, I understand why I have high latency. I'm going to batch it all together and save a lot of time. So by instrumenting the API calls, the way that Lumigo does, you're able to see even those third party, both in the system app, which is like the overall architecture view of your system, but also see the exact data when you want to see it, the exact data being sent and getting back to you from that DB call or the call to Kafka. Because if we weren't able to catch that, it would be only half the picture, and when you have half the picture in observability, you're in trouble.
So how are those API calls instrumented? It's sounding a lot to me like it's an agent-based type AOP injected thing. Is that it, or is it something different?
So actually, it's first of all, I'll say all our tracers are open source, and really everybody is more than welcome to come and see. You also mentioned OpenTelemetry, where it makes sense to use OpenTelemetry, where OpenTelemetry is mature enough. We're always happy to leverage that and also contribute where we can. The ability to see the API calls is actually different from runtime to runtime, but it is based on, let's call it, different types of injections in the right places. Again, based on the runtime and based on the right place to do it.
Now, one thing you mentioned right there is you'll leverage OpenTelemetry where it's mature enough. Where do you think OpenTelemetry is not mature enough today?
So I think that in general, OpenTelemetry is an amazing project, and I think that that's where the future will be. And in order for OpenTelemetry to be able to cover full environments, it just needs to have libraries for each and every relevant runtime and infrastructure and application. It really depends on the specific libraries that need to be instrumented. So it's not like one place. In general, I can say that OpenTelemetry is more mature, for example, of course, in tracing than it is in logging. But even when we go into tracing, we can go in and check each of the different libraries, and each user needs his own set, and some libraries are like in great shape, and some are getting there, and I'm sure they will be there, sooner or later.
So let's break out the crystal ball and let's look 5 years ahead. Well, let's not go that far. Let's say 3 years ahead. So it's now 2025. Where do we see observability and microservices all playing out? Do we even care about them anymore? Or is it just ubiquitous?
So yeah, I wish I did have a crystal ball. So, but I'll try. I'll try to give you my view. I think observability actually was always important, but it just became harder and harder as we moved forward to more and more services running in the cloud. So it will continue to be very important because things will always go wrong. You'll always need to solve issues. You'll always have high latency. I do think that the data collection part will be an integral part of, well, almost everything that's running in the cloud. Anything that wants to be, that want to be counted as production ready will need to be able to share the relevant traces. And in that way, I think that what Lumigo is working very hard on now on the collection part will be much, much easier, allowing us to focus on the more interesting part, which is the correlation, right? So you have all this data coming in, and it's actually bits and pieces of data. And the more interesting part is, what do I do with all this data? And I think that's where we'll see differences maybe between different tools, with the ability to raise up interesting insights of things which are going wrong, hopefully things that are about to go wrong based on trends and based on what has been seen in this environment and maybe in similar environments at other users' clouds. And also, I think that the ability to go from, these very generic observability tools to tools which you can have up and running in seconds or in minutes, that will also be key, because I think that observability is moving more and more into the developer teams, right? It's not a DevOps thing anymore. I think as in general, DevOps is moving into the R&D teams, and they need to be able to use this tooling very, very easily. And they need to be able to move from observability, which is, seeing what's going on, to the ability to debug it. So this is another place where we're putting a lot of focus on. So you can have the same person, maybe it's a developer oriented to DevOps or a DevOps oriented to R&D, but the ability not only to spot what's going on, what's going wrong, but immediately going to the debugging phase and trying to understand what's happening.
One thing that I feel like, by the way, I agree completely with the points you said, but one thing that I feel that people are making a mistake when they talk about microservices, hey, because of microservices, we have more stuff, more of the things. Right. Before I had one application, now I have 100 applications, and now 100 applications are so much more complicated than one, which is true. But in my head only to a limited extent, right? Because if I would have 100 times the same, it's still not a big deal, right? For me to do whatever I need to do. The real issue, I believe, that we are facing now is not microservices per se, but the variety that we are experiencing, right? Now, all of a sudden, not all applications are Java. Now we have Java, Python, Go, and Node.js in our system, right? Now, all of a sudden, we're not using some suite from IBM that IBM provided us with all the tools that we need. All of a sudden, we are using Mongos and Kafkas and AWS and this and that, right? I feel that the real problem is the variety. I mean, it's a good thing, so I like variety, but that's the real issue from my perspective. Not that I all of a sudden have to instrument 100 instead of one service, right?
Right. I agree with you. I think one of the main challenges of a modern cloud architect, and this is what makes a good cloud architect, is the ability to put aside all the noise and understand what's the best for his specific architecture. Because you have so many choices, this big variety, like you said, and you need to choose, and you need to not get too confused. And also, once you choose something, always be ready to change it if you need. Because a lot of times, something is good for some sort of scale, and then half a year later, you need to be ready and make that change to a new component. And I think that it's becoming easier and easier to make those changes. And you have these wide choices, and each time you can choose the best, Lego piece that's right for the task.
So we've taken a look at the crystal ball. We've decided nothing we can do just yet. But where are we today? What should people be doing today if they're not able to get beyond just logging? What should be their next step?
One thing that I would invest in is automation, right? So, of course, in Lumigo, automation is a key part of the product. But even if you choose Lumigo or you choose something completely else, you need to choose something that does most of the work for you, because that observability work will become bigger and bigger. And if you try to solve it yourself just by, adding more and more codes and writing more lines, it will become harder. It's fine to do it for specific things where you need to have this detailed log, or where you want this specific metric, but try to find a place where it's automated. Usually, because the more teams you have involved, the more developers you have working on your environment, it becomes harder to have one solution where everybody can go to, understand what's going on, and open up the dashboard and see, okay, this is our architecture in real time. This is not what we drew on the whiteboard like half a year ago, and we're imagining we're having different ideas of how our production looks like. This is exactly what's going on. And you'll get that only through automation, where every time somebody is adding a new piece of code, the instrumentation and the traceability, the logging, the metrics will happen automatically for him.
So we've talked about Lumigo just sort of throughout. Why don't you give a nice succinct pitch right now of, okay, what if people are trying to figure out, okay, well, what is Lumigo? Again, where do people come up with all these tech names? I'm sorry. I've been trying to figure out the basis of the name, and it's like, okay, I can't figure out from Latin roots where this came from.
Right. I'll tell you. So
okay.
When Erez and myself, Erez is my co-founder, we were looking for a name that will have some meaning in some language, but on its own won't be a word. So Lumigo, it comes from Esperanto, which is a language, but it's similar to Luminate, because we saw Lumigo as illuminating your cloud environment where, you have everything in darkness. Lumigo comes in and illuminates, and now you understand exactly what you have in the room. So it comes from Luminate, but on its own, we just like saying it, Lumigo.
Before you said that, I thought it comes from Harry Potter, something.
That's what we were aiming for. So everybody can make it up for themselves, use their imagination. But at the end of the day, I can tell them it's a real thing. I'll tell you the hardest part, which we didn't think of in advance, that too many people, when they talk about Lumigo, they say Lumingo, right? They add an N, Lumingo, just probably rolls off the tongue easier. But, you can't control everything. So that's one of the hard thing about picking a right name.
Naming is important, kids. Remember that.
Right.
And even when you're naming, start thinking of all the variations and buy all the domain names.
Exactly.
Well, Aviad, thanks for being with us today. All of Aviad's contact information is going to be down in the show notes. Again, thanks for being with us.
Thank you, Darren. Thank you, Victor. It was a pleasure.
We hope this episode was helpful to you. If you want to discuss it or ask a question, please reach out to us. Our contact information and a link to the Slack workspace are at devopsparadox.com/contact. If you subscribe through Apple Podcast, be sure to leave us a review there. That helps other people discover this podcast. Go sign up right now at devopsparadox.com to receive an email whenever we drop the latest episode. Thank you for listening to DevOps Paradox.